Well, my name is Al Karlin, and I'm with the Southwest Florida Water Management District. I'm in Mapping and GIS. That's the section that I'm with. And I'm a remote sensor. I grew up at the University of Arkansas and at Stennis, NASA Stennis. And with the Water Management District, obviously my role is in Mapping and GIS and in our Data Collection Bureau. So as I said a couple of hours ago when I introduced myself, I try to collect data. And that's one of the things that we do. I didn't bring a whole lot of slides, so I'll just say ditto to everything that we just heard. But I do have a really short story to tell you. As I told Stan, I started with the district about 8 years ago. And it was shortly after I started with the district that one of the fellows in our IT section came over to me and asked me, can I make a prediction of how much storage we're going to need in 5 years? And I think everybody here knows a person like this. Fellow's about this big. He's a little on the chunky side, red-haired, and bit on the temperamental side. So I told Jim, fellow's name's Jim, I told Jim that I think I'm going to need 4 petabytes. And Jim looked at me and he said, are you serious? And I said, yeah, I'm probably going to need about 4 petabytes in 5 years. And like I said, you all know people like this. His face got all red, and you could see the smoke coming out of his ears. Well, about a month ago, they asked me, how much data am I going to need in 5 years? And I said, probably about 4 petabytes. And I've been telling the IT structure at the district, I'm going to need about 4 petabytes for about the last 8 years, and it's kind of become a running joke. That every time they see me, and Roberta will attest to it, Jim looks at me and you can see the smoke coming out of his ears because all that IT people can think about, is 4 petabytes. How much is that going to cost? Where am I going to do? Anyway, when I think about big data, and like I say, I came from NASA Stennis, I think about in terms of petabytes and exabytes. I went around, after I spoke with Stan last week, I went around at the Southwest Florida Water Management District and I said, okay guys, how much data do we have? All told, I wanted to know every byte that we have. When you add up everything that we have at the Southwest Florida Water Management District, and we're a little bit smaller than South Florida, same 16 county number, about 10,000 square miles. When you add up every piece of data that we have, you ready for this one? We're under half a petabyte. We are under half of, and that's everything. Every piece of LiDAR data, every piece of imagery, every piece of document, every piece of remote sense data, every piece of SCADA data, we're under half a petabyte. So when we talk about big data, I wonder, Stan, do we really have any big data at the Southwest Florida Water Management District? I show you a slide that we've already seen. Steve showed a slide very similar to this, talking about how we parameterize big data. What are the parameters that we talk about big data? Volume, velocity, variety, and veracity. And when I look at the data holdings of the Southwest Florida Water Management District, I say, we really don't have any volume. We have, all told, half a petabyte, and that's with redundant storage, by the way. We have half a petabyte. So that's not really big data. Does our data change over time very quickly? And again, when I look at it, I've got to say the answer is no. It doesn't really do that. Variety, yeah, we've got a big variety of data. And if the data holdings at the district qualify as big data, that's the area that they probably qualify in, as the number and different types of data that we have. And then, of course, the veracity of the data. And that's one thing that the Data Collection Bureau has focused on very, very, very diligently, is QCing and making sure that our data really are what they say they are. So I'm going to make kind of a different argument and maybe not argue that our district has big data, but that we have a wide variety of data and focus on what we've done with it. If I can make this work. Well, even if I can't, that doesn't seem to want to work either. Ah, okay. Oh, okay. Well, instead of focusing on how we use the data and I just wanted to tell you what it is. Okay? And I'm going to tell you sort of the good, the bad, and the ugly at our water management district. We tend to name our babies, and we give them little cutesy names. And as I see it at our district, we have 4 different major databases. The big one, and it's not a big database in terms of volume, but it is in terms of types of data that are in it, is a database that we call WMIS, the Watershed Management Information System. This is our e-permitting system. You can access this online. It's open to the public. Much of the data, water levels and things like that, as well as permitting, you can find in WMIS. And right now, anyone can go online and take these data out. Of course, you got to know how to do it, and that's a little bit of a trick. So we have this one large database, and it contains, as I indicate here, our NexRad data. And as a single database, that's probably one of our larger ones. We collect NexRad data, rainfall data, throughout the entire district every 15 minutes. Now, unfortunately, you can't extract it on the every 15-minute basis from our web interface. You can extract it, however, on an hourly basis. If you want it on the 15-minute basis, you've got to make a data request, and the Data Collection Bureau will be happy to send it to you. So at least some of the data are available through the web. GWIS, the Geographical Watershed Information System, is where we keep all of our surface water data and our surface water models. Okay, this is an ArcHydro geographic database. It's like I say, it's a surface water database, and we're now adding groundwater components into it. This year, we added all of our 996 regional well data into our ArcHydro geodatabase. These databases are available through FTP. Right now, this very minute, if you hit our FTP site, you can download about 90% of our GWIS database. It's available through FTP. Or make a data request. Our 4th database, and this one is by far the largest of the databases in terms of numbers of records and in terms of data size, TIPS, which is our topographic information and publication system. This is where we keep all of our topographic data, all of our imagery, all of our LiDAR data. I counted up our LiDAR records. We have over 110 trillion records in the database. 110 trillion. WMIS, we counted up all the records there. A little bit over 2 billion records in our WMIS database. So in terms of size and numbers, far and away the largest component is our remote sense component. In TIPS, we keep all of our LiDAR data. We keep our sonar data. We have sonar data for selected areas in the district, and all of our digital elevation models. We have digital elevation models at 5-foot increments over the entire district. Labins, which is not our database, but this is a statewide database where we keep all of our imagery data. And this is available through any web browser. So we, as well as several of the other water management districts, make available all of the both natural color and false color infrared data through Labin. So these are our major databases. And I think maybe? Arrow down. Oh, okay, because that one doesn't seem to be doing anything. The right arrow. We'll try that one. Okay, I must be technologically challenged here, or left-handedly challenged. Okay, maybe that one works. Actually, there were some other slides here. Maybe we can, no, doesn't matter. So I've shown you our major databases, and I'll leave this presentation here. There's 4 slides that show a little bit of the detail on each of those databases, their sizes and some of the data that are in them. But what Stan asked me to think about were what are some of the challenges and what are some of the solutions and some of the things that we might consider when dealing with big data. And I saw a couple of challenges that our district has. And one of our challenges is our modeling data. We've been in the process now for about the last 6 months, maybe 8 months, in working with South Florida, the South Florida Water Management District, on how to make the model data available. We have all of the geographic data is in GWiz, but if you wanted to get the actual time series, the models that come out of either ICPR, SWIM, or one of the other H&H type products, they're not readily available. You've got to make lots of requests, and it takes lots of time, send us disk drives and things like that. So that's one area where we obviously need to work on. We're real good at keeping our own time series data. And as I said, we're putting more and more of that time series data into GWiz, into WMIS, in various ways and shapes and forms. But the format issue coming from outside, coming from people outside of the district is where an issue is. And I think we've seen that as a kind of common formatting issue. And I guess that topic has come up several times now. A lot of our unstructured content is not in repositories. We have data silos. It's common, and we've heard this issue being raised before. We've been going or working very diligently over the past 10 years to get the data out of data silos and into either WMIS, GWiz, or TIPS, where data belong and can be commonly accessed. That doesn't mean to say that we're perfect, and of course we're not. So we still have data on hard drives on people's computers that are not in the databases. So, and that particular problem is not well organized, and it's even not well documented where those data are. So that's another area that we see could be improved. Hydrogeological data. This has been a thorn in our side for, help me, 20 years, Roberta? More like 50 years. And it's just been an issue because of the complexity of the data, the volume of the data, and how to deal with it and formatting. Last year, we started constructing an ArcHydro groundwater database, and we're now loading the lithological and hydrogeological data into it. We've spent a considerable amount of manpower, not to mention dollars, working with Aquavea to make some custom feature classes and custom data loaders that we can get these data into out of the silos. And believe me, the data are being kept in Excel spreadsheets on about 3 different computers. And I think everybody understands and has experienced that sort of thing. So that's another area. And then the last area, of course, is just content management, contracts, white papers, procurement things, and things like that. Just getting them into a content management system where they're easily accessible. So those are what some of the challenges that we see. See if I can get. Nope, not going to make it to my last slide. The two solutions that, or two of the solutions that we think might work, and one of the problems, one of the solutions, is people. We see big data as a personnel resource issue, where we have the ability now through our technologies to keep lots and lots of data, lots and lots of different places. We can crowdsource things, but if people don't know how to get to them, it doesn't matter what the data are. It doesn't matter where they are. If people don't know how to access the data, or if they can't get to it, that's a real problem. So we see personnel and knowledge-based things as an issue. we need to train our next generation in things like R, using R to do data extraction. They need to be better trained at using the computing resources that are available to go out, search the web, and find the data that they need to put into whatever models and whatever analytical apps they're going to do it, they're going to use. So we see not so much a technological issue, but a personnel issue to using and exploiting big data. And unfortunately, that slide didn't show, but if Stan distributes the deck to y'all, you'll get it. That's all I have to say. Thank you.
Right, in terms of your hydro and hydrogeo data, you might have to look at the National Science Foundation program for critical zone observatories. So there's a network of these watersheds that are concentrating on the stream surfaces and the geology below them. And there are 8 of these sites, and they invested a lot of money in creating a database that all the sites would put all of their data in, and it's the kind of data you're talking about.
Let me get a website.